All right, so here again is our last example, example 2, and we're going to find the antiderivative using the rules that we just talked about in the last video. So here, we're going to be dealing with each one of these rules. And so here we know we have the constant multiple rule happening in A. So our constant multiple rule. Right, it could be great. All right, so constant multiple rule means that all we do is add 1 to the new exponent and divide by that new exponent. Add 1 to the exponent and divide by the new exponent. So f, big F, so for antiderivative, we do 3, we add 1 to the 7, and then we do 7 plus 1. So that would be 3x to the 8th power, divided by 8. And that's it. That's the answer. Oh, sorry. One thing I did forget about the rules. We have to have a plus C on the back of them. Oh my gosh, I forgot that quickly. The back of we have to have that plus C in the back because it means a constant that was originally there. So if we're going back to the original function, that means we have to have a constant in the back of it to actually say, okay, there was something back here before we found our derivative. So before, if you think about it, if we took our derivative of this function, let's say we had 3/8 x to the 8th power plus, let's say, 5. Just to throw it in there. That's not actually part of the problem, but just throw it in there. You know, if we find our derivative, that means we're taking this exponent and moving it down. And then we'll take the derivative of a constant, which is just 0. So here, if we do that, that means we'll have 8 times 3/8 x, the 8's will cancel out, x to 7, sorry. And we're left with 3x to 7, which is what we originally started with, right there. Now, with this, because we don't know what that constant is back here, because this number could have been 10, it could have been 20, it could have been 15, it could have been 7, it could have been 5, like we had it. But we don't really know what that number is. So here, we do a plus C on the back of it to make sure that we do have, we account for that constant that was originally there. The constant could have been 0. Like here, this could have been a 0 for the 5. But we still have a constant there. So we need to make sure that we do that plus C on the back of each one of these. So with that, I'll go back and actually add that to the videos for the rules. So here, always do that plus C on the back of it. Always plus C for antiderivatives. Always. Always, always, always. All right. So I'm going to go ahead and erase this part here. We don't need that right now. So always have that plus C. All right, so when we do this portion here, we're going to find the antiderivative and do a plus C in the back of it again. Right, so here, again, we're going to add 1 to the exponent and divide by the new one. So we do 2 plus 1, that's 3, divide by 3. We understand this, so understood 1 right there. So we do 7 x plus x to, 1 plus 1 is 2. So in other words, 1, we add 1 to it, that's 2, divided by 2. And then here, if we look back at 5, this x to the 0 power. Because remember, anything to the 0 power is just 1, so that's 5 times 1, so just 5. So here, we're going to do x. I'm going to add this step in so you can see it. So we have that part. And so really, that's just 5x to the first power, or 5x. So our antiderivative is this. And again, don't forget that plus C on the back of it. Plus C. Easy, simple, not hard, right? We got this, we got this. All right, so then the next one, I think this is the last one. It is the last one, cool. Again, just like we talked about before, we don't know how to do multiplication when it comes to antiderivatives. So that means here we're going to go ahead and multiply it out first and then do our antiderivative. So distribute this x to both of these. distribute. So here we'll do, before we actually move into the antiderivative, is x cubed plus 2x. And so here, all we're going to do is just add 1 to the exponent and divide by the new exponent. And just as a reminder here, we had a subtraction for this problem for b and addition here. So we know this is difference, this is difference, this is sum. And then here we have an addition sign, so that's just sum. So, right, so we're going to go ahead and just do a problem now. So x to the fourth over 4 plus 2x squared over 2 plus c. And again, remember, if it's understood 1, you just add 1 to it, gives you 2. Right? So here, it's a quick thing. The 2's will cancel out with x to the fourth power over 4 plus x squared plus c. If you can simplify it down. If it's possible, do it. And that's our answer. That's it. So it's not hard at all. We got this. We got this. Shoot. And again, if you need help and stuff, just let me know. We can do more practice with it, which I'm assuming we will, and it's okay. All right. So then here's your homework. Page 958. Numbers, questions 20 through 30, and then 36 through 42, and that's all even. All even. So 20 through 30 is all even, and then 36 through 42 do just the even problems also. So even, Steven. 8.